The next one. Next we are having it is testware. That is the documents created during testing activities are known as testware. So here testware are the documents whatever we are generating or creating when we are testing that particular product is your testware. So then it comes the terminology of incident. So when a failure occurs, it may or may not be a readily apparent to the user. So an instance is a symptom associated with a failure that alerts the user about the occurrence of failures. So instance is nothing but whenever you are testing anything, whenever we are getting any failure, so that message we will be getting. That is, we could able to find or we could be able to get some message that we are having a failure in the particular module or in particular product. So that knowing those things is our what we can call it as an incident. So then we are having test oracle. That is so an an oracle is the means of judge the success or failure of a test. That is to judge the correctness of the system for some test is we are going to say it as the test oracle. So the simplest oracle is comparing actual results with the expected results by hand. Okay, that is so we will be assuming some results at the beginning. That is those results we are going to say it as the expected results. But whatever we are getting after computing our product is our exact result. That is actual result. So the difference or showing the difference between these two is our test oracle. Okay, so we are having the different terminologies like so in software testing terminologies, we are having the definitions or terminology like failure, fault, defect or bug, error, and then we are having test case. And in test case, we are having test ID, purpose, preconditions, inputs, outputs, that is maybe expected outputs, and all those things we are having. And then we are having testware, that is the document, whatever we are doing at the time of testing is our testware. And whenever we are getting any failures during the testing is our incident. And then we are having test oracle, that is judging of that particular document. So then we are having the life cycle of bug. Okay, so if you can see the picture is going to give us the life cycle of a bug. So it is going to have the various phases again, like requirements gathering and specification, design, coding, right? So then it is going for testing, right? So after testing, it is going for the classifying of the bug. Then it is going for the isolation of the bug, and then it is going for the resolving of bug. So these phases we are going to say it as the bug life cycle phases. That is life cycle of a life cycle of a bug. Okay, that is we will be having requirements gathering and specification. Then it is going moving on to the design. Then it is moving on to the coding. Then it will be going for testing. So when there is a testing, so then it is going to be classified whether it is a good bug or bad bug, that is incident bug or something is happening in the code. Then it will be going for the solution, and after the solution is done, that is resolving is done, then the bug is going to complete its life cycle. So this is related to the life cycle of a bug. So in phase wise, if you are going to see, so we are going to have the requirement phase, design phase, coding phase and testing phase. So then we will be having the classification of the bug and location of the bug and resolving of the bug. Okay, so that is what is there in the life cycle of bug. So similarly, we are having the states of a bug. So we are having states as new state, open state, assigned state, deferred state, rejected state, test state, verified or fixed state, and reopened state. So that is so whenever a bug is going to be detected, so we are going to have multiple number of states, just like our process states. Okay, just like we are having new, ready, running, blocked or waiting and terminated state in operating system, here also we are going to have the states of a bug. So bug is going to be having multiple states like new state. So the new state is when the bug is reported first time by a tester. Okay. So when a tester is going to test any of the module or any of the component or any of this code, if it is reported first time, then we are going to say it as the new bug. So after reporting, when we are going to uh, check, that is called as our open state. That is, we have already found the bug. Now we are going to open the bug and we are going to perform the operations on that particular bug. That is rectifying it or removing it or some modifications we are going to do. So then the bug is going to be coming for the assigning phase. That is, a team is going to be assigned for fixing that particular bug, and that team is going to check with the bug and they are going to go for the solutions. Then comes the deferred bug. The developer who has assigned to fix the bug will check its validity and priority. That is, so how important it is in solving the, sorry, how important it is for solving that particular bug. And if we are going to solve this bug, what are the benefits that we are going to get? All these things will be seen in the deferred state. And then we may reject the bugs, as if it is going to be minute bug, we can simply reject the bug after checking the its validity. And then we can go for the testing. That is, after fixing the valid bug, so if we are not going to clear this particular bug, if it is going to be affecting, then we are going to go for the testing of that particular bug, and then we are going to verify. That is, that is, tester is going to test the software if the bugs is fixed or not, and if it is going to be, then he is going to verify. That is, he is going to do the changes and he is going to go for the verification. Then he is going to go for the reopening. So if everything is done, then he is going to verify it and he is going to close it. So if it is not done, then again it is going to be reopened. Okay. So here we are having the states of a bug, like new state, open state, assigned, test, verified, closed. Right. So once it is assigned, then it has to be deferred or rejected. So if it is rejected, that is fine, well and fine. So if it is deferred, that is also well and fine. So if it is assigned or moving on to the test phase, it has to be verified and it has to be closed. Okay. So these are the states of a bug we are having. So then why do bugs occur? Right. So these may be considered as the human errors, or wantedly we are going to create the bugs in the particular what we can say in the development of the software. So here the bugs affect the economics of software testing. So bugs uh, when you are going for the economy. So whenever you are getting any kind of bugs or any kind of errors or bugs, defects we are getting, we need to overcome with the help of the solutions. So for that solutions, we are going to be costed, right? So that cost we are going to say it as the affect economics of software testing. Okay, so that is the case of the bugs affecting the software testing. So then we are having bug classification based on criticality. That is criticality. So we are having critical bugs with respect to major bugs, medium bugs, and minor bugs. So if the tenure is okay, that is, if we can solve it within a limited period of time, then we are going to say it as the minor bug. If it is taking little bit more time than the minor bug, we are going to say it as the medium bugs. So if it is taking longer bugs, we are going to say it as the major bugs. So even though if it is taking longer time or shorter time, But if we could not able to find any solution for the bug, then we are going to cite as the critical bugs. So finally, we are going to find the solution, but it is taking uh, some extra time, we can say. So then we are having the bug classification based on SDLC. So that is software development life cycle. So as we have different phases in software engineering, here also we are having the different phases in SDLC, starting from requirements and specification bugs, design. Then we are going to have the coding bugs. Then we are going to have the interface and integration bugs. Then system bugs and testing bugs. Okay. So while coming to the testing principles, it is effective testing is not exhaustive testing. So as we discussed in the previous sessions, so these concept we can relate to those myths and reality, right? So these are all the various principles that we are having in the myths and reality as well. Okay. So this is related to the software terminology and its importance in the software testing. Okay. So is it clear, guys?
Yes, sir. It's clear.
Okay, fine. So quickly moving on to the next topic, that is your second topic of this particular portion. So which is called as STLC. Okay. So just like our SDLC, that is software development life cycle, we are also having STLC. Okay. So here the STLC is having various phases. We can see all these phases here. So we are having basically four different phases, which are called as test planning, test design, test execution, or test review. Okay. So in the first phase, we are going to go for the test strategy. That is size of the test cases, duration, cost, risk, and responsibilities. All these things we are going to plan at the time of test planning. If you are taking up any project, so what is the test strategy that we are going to apply, whether it is top to bottom or bottom to top, white box, black box, or any of the test cases or test strategy that we are going to apply, that we are going to check. And then the size of the test we are going to check. And then the test cases, that is size of the test cases we are going to check, whether it is small, medium, or large, or extra large, that we are going to check. And then we are going to check for the duration. So when we are going for the testing, so is it going to be taking months of time, or weeks of time, or days of time, or maybe years of time? So how much time period is going to be taken for this particular testing, we are going to check. And if you are going to go for the duration and testing of all the other things, we are also going to check with the cost that is related to that particular system, that is that particular product. Then we are going to check with the risk, responsibilities, and other aspects that are related to the uh, particular software which we are going to go for the testing. Okay. So that is related to test planning. So before we go for testing, we will be planning how we could able to execute that particular testing. Okay. So these are the uh, areas where we are going to test, or where we are going to plan for testing before we start our testing. Okay. So then moving on to the test design, then we will be going for the test cases and procedures. So we will be coming out with the test cases. What are the multiple number of test cases that we are available with within the particular product? And then we are going to go for checking for all the test cases and all the possibilities. What is the success rate? What is the failure rate? What is the result? That is what is expected to be coming out, and what it is giving us. All these things we will be checking. And then we will be going for the execution. And then in execution we are going to go for the following the all the procedures. And then we will be reporting the bugs. If we are having any bugs, then we are going to give the metrics as well. So when it is finished, that is deployment is done to the customer also. So post execution also, if you are going to get any kind of errors or any kind of mistakes or any kind of bugs, so the feedback is going to be taken from the customers or from the stakeholders, and again the process is going to be going for the design phase, that is test design, where our test cases and procedures are going to be followed, and furtherly we are going for the execution, and again bug reporting and bug metrics we are going to go, and finally we are going to go for the review, that is how it is functioning, how it is giving the results, and how it is showing the better performance in the market. We are going to check with the help of this particular four different phases. Okay, so this is called our software testing life cycle. So in which we are having test planning, test design, test execution, post execution or test review we are having. Okay, so is it clear? Yes, the phases is it clear? STLC. Yes, guys, anyone is there?
Yes, sir.
Yeah, is it clear? Yeah, I could able to find people, but no response. Right. So if it is clear, then we can move on to the next one, that is software testing methodology. Okay, so where again we are going to have the strategy, that is testing strategy will be there. So where we will be having the test factors, test phase, verification and validation. Okay, so in verification, we are again going to have several features, and in validation also we are going to have several features. So coming to the validation, we are going to go for unit testing, integration testing, and system testing. And coming to the verification, simply we are going to verify whether it is perfect to fit in the modules or not. We are going to check, and then we are going to go for the next level of proceedings, and then we will be having the test tactics. So in software testing methodologies, we are going to have these test tactics. So where we are going to have the testing techniques and testing tools which are available for the users in the particular software testing or testing strategy. So coming to the testings, we are going to have the static testings and dynamic testings. So here we are going to see the, in dynamics we are going to see the black box testing and white box testing. So this is our testing methodology. Okay, so in testing strategy, we are having two different strategies. One is verification and the other one is validation. So after verifying each and every aspect of the project or each and every aspect of the product, we are going to go for the testing aspects. So that is testing uh, factors. Okay, so that is testing techniques. So in testing tactics, we are having testing techniques and tools. So in techniques, we are having static and dynamic. In dynamic, we are having white box and black box testing for our testings. Okay, so here the test factors, test phase, test strategy matrix, that is how you need to select the rank test factors, how you need to identify the system development phase, how you need to identify the risk associated with the system development phase. So everything is going to be there in the software testing strategy. That is, so test factors we are going to check, and after that we are going to go for the each and every phase. That is, we are going to call it as the test phase. So then we are going to check with the test strategy matrix, where we are going to have the rank, where we are going to identify the development phase, and we are going to identify the risks that are associated with the particular testings, and then we are going to create a test strategy, and there we are going to give the uh, probabilities of each and every phase, starting from requirement phase to the development phase, that is requirements phase to the deployment phase. And then we will be seeing the development of this test strategy. So how it is moving from verification to the validation, and how it is coming out for the users. And then we will be seeing, then we will conclude, or we will say, with the help of testing life cycle model. So that is V testing life cycle model. And so V testing life cycle model, or V testing model, is having your development phase will be there, tested system will be there, and starting of your testing will be there. So where we will be having the verification and validation, and we will be concluding with the verifications and validations. So then we will be having with the expanded V testing model, where it is going to include each and every phase of the life cycle model. So where we will be defining the specifications, design related aspects, coding related aspects, and integration related aspects we will be seeing. So similarly, we will be checking for the verification, that is specifications, design, unit test, and integration test also we will be checking with the help of our testings and implementations. And then we will be concluding with the validation activities, that is whether all these modules are valid modules in this particular project or not. We are going to test with the help of unit testing, that is self testing, and integration testing, which is the intercommunication of the multiple tests or the multiple modules, we can say. And then we will be going for the complete analysis of the system testing. So coming to the testing tactics, we are having software testing techniques. So like static testing and dynamic testing. So in static and dynamic, in static testing, we will be focusing on the static aspects that we could not able to modify. So, but in dynamic testing, we could able to modify the things. So with the help of black box testing, that is top to bottom, and white box testing, that is bottom to top. Okay, and we will be having the testing tools for testing all those things. And then we will be having the consideration in developing testing methodologies. So where we will be determining the project risks and how we need to overcome all those project risks with the help of our uh, building a test plan. Okay, so this is what is there in this particular portion. Clear?
Yes, sir.
So what we are seeing in software testing methodology, we are having testing strategies. So where we are undergoing two different processes. One is verification, whether it is fitting into the project or not, we are checking. And then we are going to validate it. That is whatever the modules that we are including, or whatever the things that we are including into the project, we are going to validate with the help of unit testing, integration testing, and system testing. And then we are going to go for the testing techniques. So with the help of testing tactics, we are going to have the testings. In testing tactics, we are having testing techniques. So again, in testing techniques, we are having multiple types, that is static and dynamic. So static things are not going to be modified, but in dynamic testings, we are going to modify the errors with the help of top to bottom and bottom to top, that is with black box testing and white box testing. Okay, so these are the three topics which we are having in the second part of your first unit. So that is the second part. And quickly, so if it is okay, we can move on to your next part. So that is our verification and validation. So previous topic is clear,
Yes, sir.
right? So in verification and validation, that is double V, we are going to have. So the main objective over here is V diagram provides the basis for every type of software testing. So various verification activities we will be seeing, and various validation activities we will be seeing. then how to perform verification at each stage of SDLC we will be seeing, and various validation test plans we are going to see. Okay, so here verification and validation is simply nothing but we are going to say it as V testing. V testing. Okay, it is going to be in the form of, sorry, it is looking like V. Okay, so the first phase or the first thing we are going to say it as our uh, what we can say it as the start development is going to be our first phase. Then we are going to go for the tested system, and then we are going to have the start testing. That is, start development will be on the one side, start testing will be on the other side, and both will be reaching to the tested system. Okay, so in the V shape, that is in verification, we are going to say it as V testing. So start development will be on the one side and the start testing will be on the other side, right? So for testing side, we are going to have the checking of specifications. That is what we have specified, we are going to check, and checking of the design. So what was the design that we have chosen, that is going to be checked. Then it is going to check for the unit testing, and integration and system testing is going to be tested with the help of testing, that is start testing side. Okay, so while coming for the other side, that is implementation. So this side we are going to say it as the testing side, and the other side we are going to say it as the implementation side. So in implementation, we are going to define the specifications. Okay, and then we are going to go for design, and then we are going to go for the coding part, and then we are going to go for the integration. So which is starting from uh, defining the specifications till the integration. So that's why we have given the arrow from the top to the bottom. So here also it is checking for the specifications, checking design, unit testing, integration testing. We are going to go for the top to the bottom. Okay, so that's why the arrow mark is again given from the top to bottom. So whatever the process that we are doing in verifications are, so what we are verifying are, we are checking for the specifications. That is, what is the user has given us, and what we are specifying, and what we are checking. So we are defining the specifications and we are checking the specifications. So defining is done on the one side, and checking those specifications is done on the other side. So design part is being done on one side, right? So that is on implementation side, and testing of that particular design part is being done on the other side. That is, check design is going to be happening on the other side in parallel. So coding part is happening in one side, and unit testing is going to be done on the other side, right? So that is in parallel we are having all these things. Okay, so here verification is going to be done on these three aspects: specifications, design, and coding. And checking the specifications, checking the design, and unit testing is, all these things are going to be done in the verification. So when it is coming for the validation, we are going for the integration and system testing on the other side, and implementation side, we are going to go for the integration. That is, we are going to integrate all the modules, individual modules as a single unit. Okay. So this process, complete process, which is undergoing in this particular figure, we are going to say it as the V testing. So V testing is for verification and validation. So verification is going to be done on the other side, and validation is also going to be done uh, parallelly. Okay, verification and validation both are going to be done with the help of V testing. Okay, that is the basics of verification and validation. So here, so hope this one is clear. V testing is clear.
Yes, sir.
Okay. So moving on to the first topic of verification and validation activities. So verification and validation activities are also going to be in the form of SDLC phases, that is software development lifecycle phases. So similar to our SDLC, we are also going to have the verification and validation activities as a process. So what are those activities? First, let us check. So here we are going to have the end user requirements gathering, requirement specification, objectives, functional design, and high level design, right? So internal design, low level design, and coding. So these are the SDLC phases, we can say. And we are having one more picture which is having tester performs verification prepares test plan during every SDLC phase. So how the tester is going to perform the various aspects that is there in this particular second figure. So coming to the first figure, we are having just like our SDLC phases. Those phases are only described or given over here in the SDLC. So where the user is coming to a company or an organization, he is saying about all the requirements that he is in need of for a development of a project or product. So the company is taking the entire information, that is requirement gathering phase is being done. So after the requirement phase is done, that is requirement gathering is done, they are undergoing for requirement specification or objectives, that is what are the requirements of the user and how we can fulfill those requirements with the help of our inputs and all that we are going to check, that is that the team is going to check. And then they will be going for the functional and high level design, functional designing and high level designing of that particular product. And then they will be going for the internal design, that is after designing the functionality or functional level designing, they are going to go for the internal, that is functionalities. If they are specifying, so within that functionalities, how many modules can be included or how many sub modules can be included, those level of inclusions are also going to be done with the help of this our SDLC phases. Then coding is going to be done. Then they will be going for the testings and all. Okay. So all these phases are our SDLC phases. Okay. So coming to the testing. So here in testing, it is going to be done in two different formats or two different things we can say. So one is verification and the other one is validation. So if you could able to check, so here we are having verification, and that is a tester, how the tester is going to perform for the verification of the requirements that are being kept by the users. Okay, that is by the company or the organization. So here in verification, end user is always going to be there, right? So requirements gathering will be there. So from the gatherings, so what is the accepted test plan that they have taken or undergone, or what is to be taken is going to be specified. So then after the gathering of the requirements, so requirement specification objectives have to be again verified, right? So for that also we need to go for the building system test plan, that is build the system test plan we need to go for. And then we have to again go for the functional design and high level design. Then we have to go for internal or low level design, and then we have to go for the coding. Okay, so in all these phases a tester has to undergo the process of verification, that is whatever the user has given the instructions to the development team, whether they are following them or not, they have to check. Okay, so from end user also they are going to take the inputs, and from the team they are going to take those model or module, and they are going to test for the verification, that is they are going to verify all those things in that particular case, that is verification they are going to do. So similarly in each and every phase they are going to go for the verifying whether it is there or not, that is whatever the customer has given to the development team, whether they have kept or not, they are going to check. That process is, we are calling it as the verification phase. So coming to the validation phase, then whatever the things that they have kept, That is, so if the user is asking for 5 modules and the development team is producing 5 modules, right? So if they are accepted or not, that is going to be done with the help of validation. Okay, so whatever you have kept is valid or not, that a tester is going to test, and that is, he is going to give you the feedback. Okay, so this is our V and V diagram, we can say. So verification will be done in all the phases, and the planning is going to be given, and validation is also going to be done with the help of the acceptance testings, system testings, integration testings, and functional and integration testings, and unit or validation testings. Right. So this process is going to be a continuous process throughout the project, or throughout the complete flow of that particular product, we can say. Okay, so this is related to our verification and validation. So where it is having various phases like SDLC. So whatever the required information is provided by the user to the development team is going to be verified by the tester. After verification also, he is going to undertake the testings, and then he is going to go for the validation of that particular testings. Okay, so these things are going to be happening in as a bunch of activities in the verification and validation activities. Is it clear?
Yes, sir.
Right. So quickly moving on to the again the same topic, that is verification. Again we are having. So here uh, what are the things if the verification is not going to be done, and what is to be done in verification are given over here. So if verification is not going to be done, we are going to get multiple number of errors. So if early verification is going to be done by the tester, then we are going to go for the less cost. If you are going for the verification at the later part, it is going to again give us the more or much cost for the users. That is, we are going to be charged more amount because it is having at the lateral part, right? So to avoid such things, everything must be verified. That is, starting from the requirement phase till the last phase, everything must be uh, verified properly throughout all the phases. So results of verifications may not be binary, that is zeros and ones. So it has to be either written or it has to be in the form of documentation. So even implicit qualities must be verified. So whatever we are giving implicitly or explicitly, that is internally or externally, that has to be verified properly, right? So in verification activities, again, it is going to have the high level objective design and low level design and coding or unit verifications we are going to have. Okay, so this is related to the verification. Okay, so coming to the verification of requirements. So what we are going to check over here, simply we are going to check for the uh, requirements. That is, simply we are going to verify what are the requirements that are being given by the user to the development team, and what are the things that are being kept by the development team, so that we need to test. So when we are going for these kinds of things, we are going to check what are the main objectives of the user of giving us the project. Then we are going to verify the requirements and objectives again. So then we are going to go for the correctiveness. That is, if anything is missing, that is, whatever the intentions of the users are there, if it is not matching with the product, then we are going to go for the correctiveness. That is, we are going to make it as correct. And if it is uh, ambiguous, we are going to make it as unambiguous. That is, no clumsiness in the project we are going to do. Then we are going to make it as a consistent project in the market. That is, capable of doing all the things, then we are going to do it as the complete project. That is by verifying each and every aspect of the phase. We are going to do that particular thing, and then we will be going for the updations. That if it is anything is to be modified or anything is to be updated, that we are going to do, and then we are going to go for the traceability. That is wherever we are having any kind of mistakes or any kind of mistakes or bugs, if you are having anything in the project, that we are going to check and we are going to verify them. So in this particular thing we are going to check from the top to bottom and bottom to top, so which is said to be as the backward traceability and forward traceability. If you are going from the top to bottom, it is going to be said to be as the forward traceability. That is, we are tracing the project from the top to the bottom. And if you are going from the bottom to the top, then it is said to be as the backward traceability. So that is the process which we are going to follow in the verification of requirements. Okay, so that is verification of requirements. So we are going to verify each and every aspect related to our requirements. Clear?
Yes, sir.
Right. So quickly moving on to the next one, that is verification of high level design. So simply what we are doing is, so we are testing for each and every phase as a separate heading, and we are writing or we are discussing all the things related to that particular phase. Okay, so first phase we are having is requirements. So after requirements we are having planning. So in planning we are having the high level design, that is how the structure of the project has to be, or how the structure of the product has to be verified in this particular level, that is high level design. So how to verify high level design in the sense, so here we need to go for the data design, architectural design, interface design, and verification of data design, verification of architectural design, and verification of user interface design. That is, we need to go for designing a module for the given project or assigned project. Then we need to undergo the testing. That is, architectural diagram has to be there, and in architectural diagram also again we need to have the explicit modules and implicit modules. That is, modules have to be there and sub modules have to be defined. Okay, each and every modules have to be defined, and then we are going to verify whether all the modules are being there or not. We are going to verify. That is, so verification of data design, that is how the design is there and how we are looking that particular design, and how the design is useful for the users, that we are going to check with the help of verification of data design. Then coming to the architectural design. So how the architecture is, whether it is a mesh architecture or star architecture or any other architectures that we are having in the market, that we are going to check, and then we are going to verify that particular architectural design. So finally we are going to go for the user interface design, that is how the modules are being developed, how the sub modules are being developed, and how the integration part is taking place in these particular modules is going to be taken care with the help of this particular verification of user interface design. Okay, so this is related to only explicit modules, that is main headings, whatever we are going to get in our particular project. Okay, so in low level design, that is verification of low level design, we are going to check with the sub modules, sub modules, and all those things we are going to check in this particular low level design. Okay, so then we are going to check for the code. Okay, so for code, how we are going to check, that is how we are going to verify. We are going to check each module at a time, that is unit testing we are going to done, and then we are going to go for the system testing, that is complete testing we are going to undertake. Okay. So if that is okay, then we can move on to the validation. Clear, guys?
Yes, sir.
So what we are doing, we are coming step by step with the SDLC model, where everything has to be verified by the tester. Okay. So whatever the previous class we have seen yesterday, for that we are coming little bit extension. Okay. So coming to the validation, what is validation in the sense? So whatever the verifications that we have done, so whether it is valid, that is whether it is fitting into this particular product or module or not, we are going to do validation in this particular project. That is with this particular step, or in this particular step we are going to validate the verified modules or verified code, verified sub modules or verified things, that is planning, designing, everything we are going to validate. So if it is validate, that is, so if the plan is okay, then we are going to approve that particular plan, that is test plan, that is validation of test plan we are going to say. So if designing is okay, then we are going to validate that particular design. So when we are going for this particular validation of test plan, we are going to go for the acceptance test, system test, right? So then we are going to go for the function test, integration test, and unit test. So acceptance test is done whether this project is going to be uh, carried forward or not. So that is whether each and every aspect is being included from the customer's end. We are going to check, that is we are going to make ourselves as accepted. That is, so these are the requirements that are being given by the customer, and we are accepting it and we are validating it. That is, requirements verification is done and the validation is also going to be done with the help of our acceptance test. Then we are going to go for the system test plan. That is where we are going to check with the SRS and all the other aspects that are related to the document and the modules. Then we are going to check for the functional test. That is how the functioning of the module is, whether it is giving us the correct output or not. So if it is giving, then what is to be uh, taken care. So if it is not giving, then what has to be improved in that particular functionality. All these things we will be taking care, right? So in integration testing, we will be checking for the interfaces within the modules and how the integration is happening within that particular project. And after the integration, how the results are coming for the users, we are going to check. Okay. So then we will be having, so if everything is done, then we will be having a unit test that is prepared for LLD phase, that is um, low level development phase. So it consists of test plan of every module, right? So it is having a test plan of every module, sub module, that is low level modules it is going to have, and it is going to go for the unit testing of each and every sub modules as well, right? So then validation test execution. So how to validate the test execution? Okay. So unit validation testing is going to be done, that is sub modules are going to be tested and validated. Then integration testing is going to be done and validated. Then functional testing is going to be done and validated. Then system testing is going to be done and validated, and acceptance test is going to be done and validated. So finally, installation testing, that is if it is a software related project, so we are going to go for the installation testing also, and we are going to check for the compatibilities and all in the validation testing itself. Okay, so this is related to our verification and validation. Clear?
Yes, sir.
Right. So quickly moving on to the what we can say. So quickly we will move on to the yesterday's paper. So which is being shared by the sir. Okay. So I will read out the question. So if you could able to answer those questions, then it is well and good. Okay, so let me read out those questions. Right. So first one is state the myths and facts about the software testing. State the myths and facts about software testing. So have we covered, just covered or not? So if it is covered, uh, how many myths are there?
Seven, sir.
7 myths are there. Okay, what are those myths? So do you remember, or are you writing any running notes, or you are having already notes with you? Do you have the notes? Whatever the notes that is being dictated in your classroom or running notes? Yeah, okay. I did not get any response. So it is fine. So if you're not having also, if we are having this textbook right with you, it would be better. So it is also there point to point. So we are having 7 different myths. That is, testing is a single phase in SDLC. So testing is easy. Software development is worth more than testing, right? So complete testing is possible. Then testing starts after program development. So the purpose of testing is to check for the functionality of the software, and anyone can be a tester. So like that, we are having 7 different myths in the software testing. Okay. So the next question we are having is explain in detail about the relationship between software test life cycle and software development life cycle. So how many phases are there in SDLC and STLC? STLC and SDLC. Yes. So what are the phases in STLC and what are the phases in SDLC?
In STLC, we are having 4 phases, sir. Test planning, test design, test execution, and post execution or test review. Whereas in SDLC, we have 6 phases: end user requirement gathering, requirement specification or objectives, functional design in HLD, internal design in LLD, and coding.
Okay, that is good. That is the answer. And do we have any relationship between those STLC and SDLC? That is the question.
Yes,
Yes, do we have any relation? Yeah.
yes, TLC is a subpart of SDLC.
Okay, you are saying STLC is subpart of SDLC. Okay.
Yes, sir.
So we need to write how it is same. That is how it is related to STLC and SDLC. Okay. So that is related to the STLC and SDLC. Then the next question is discuss in detail about evolution of software testing. Evolution of software testing. Evolution of software testing. The first topic which we have covered is our evolution of software testing. So where you are having before 19 sorry from 1950s, right? So that is before 1957, then 1957 to 78, then 79 to 82, and 83 to 90, sorry 87. Then we are having 88 to 95 and 95 onwards. Okay, that is the evolution of the software testing that you need to answer. Okay, so explore on software testing methodology in detail. So what could be the answer that you can write? Software testing methodology. They are asking your second chapter complete name as your question. What can be the answer that you can write? Software testing methodology. They are asking, so what is software testing methodology? That is explore on software testing methodology in detail. They are asking the question, software testing methodology in detail.
Software testing methodologies are used to guide software process, sir.
Okay,
They
and
are
you can also, okay,
various software testing methodologies like white box testing, black box testing, like that, sir.
okay. Everything you can include from your second unit, first part, like your software testing terminologies you can include, right? So then you can go for your uh, life cycle of bugs, life cycle of states of bugs. You can write software testing methodology. They are asking that. So then you can go for your second topic. So which is named after software testing life cycle, that is STLC. You can take and you can write and you can explain, and then you can go for software testing methodologies. Okay, so in software testing methodologies you have to go for the testing strategy where you are checking for verification and validation. So in validation you are checking for unit testing, integration testing, system testing, and in testing tactics you are having testing techniques and testing tools. So in testing techniques, again, you are having static and dynamic. There you are having uh, black box and white box testing. Okay, so in testing strategy, we are having test factor phase and test phase we are having. So those things we need to write when we are giving for the exam. Okay, so as a separate topic, we are having it. We can go for that answer. So if it is not there, then you can go on elaborating the complete part of that particular second unit. Okay. So that is sorry, the first part of sorry, second part of your first unit. So with that, we have done with our first unit. So then, what is there in your second unit? Okay. So testing techniques, is it the same thing that is there in the second unit?
Yes, sir.
Just wait for a minute once again. So in the second unit, we are having dynamic testing, so which is uh, black box testing techniques, boundary value analysis, equivalence class testing, static table based testing, decision table based testing, cause effect graphing based testing, right? So those things we are having. And in white box testing, we are also having the made logic coverage area, basis path testing, graph matrices, loop testing, data flow testing, and all those things we are having in the second part, right? So dynamic testing, yeah, okay. So once again, I will start sharing my screen. Right. So this is the testing techniques that we are having. Right. So after reading this particular chapter, we could be able to easily understand that is what is dynamic testing. In that case, what is black box testing? So what is white box testing techniques? That is what are the black box testing techniques? What are the white box testing techniques? And then what is static testing, then what is validation activities and regression testing we are going to check. Okay, so out of all these things we are having hopefully the first three topics in your syllabus. Okay, so we are having only two topics, that is okay, static testing, regression testing is also there as separate unit we are having, static testing and validation testing. Okay, so here we are looking into the next topic, that is dynamic testing. So which is also called as the black box testing. So there we are having black box testing techniques also we are having in the uh, okay. So black box testing strategies we are having and white box testing strategies we are having. Okay. So in this particular portion, that is in testing techniques, we will be focusing on the dynamic testing techniques, static testing techniques, validation testing techniques, regression testing and techniques we are going to check, and we are going to go for the solution. Okay. So coming to the testing category and the different testings we are having are displayed in this particular figure. Okay, so in first testing, that is in dynamic testing, so which is also the other name for the black box testing and white box testing. So in black box testing, we are having boundary value analysis. That is where the boundaries are going to be defined. Based on those values, we are going to analyze the testings. That is what is the module size and how we are going to go for the testings and all. We are going to go with the help of boundary value analysis. That is fixed boundaries, just like in cricket and in house constructions, as we are having some boundaries, here also we are going to have the boundary value analysis in the testings of black box. Okay, so in the second test we are going to have the equal class partitioning, that is equivalence class partitioning we are going to have, and there we will be dividing each and every module or dividing each and every phase into equal partitions, and then we are going to go for the testings. Then we will be having state table based testing, then we will be having a decision table based testing, then we will be having cause effect graphing technique, and then we are having error guessings in this particular uh, dynamic testing called black box testing. So coming to the white box testing, we will be having basis path testing, that is basic path testing we can say, and graph matrices, loop testing, and data flow testing, and mutation testing. So these testings we will be seeing in the next part, which is as our next part of our second unit. So then we will be checking for the static testing. So where we will be having inception testing, walkthrough, and reviews. Okay, then validation testing indicates or includes the unit testing, integration testing, functional testing, system testing, and acceptance testing and installation testing. Okay, so then in regression testing, we will be having selective retest techniques, test prioritizations we will be having. Okay, so quickly moving on to the first part, that is dynamic testing, that is black box testing strategies. So in this chapter or in this case, we will be checking for the black box testing and how it ignores the structure details of the software, and then test case designing using black box testing techniques, then boundary value analysis method, then equivalence cross testing method, then state table based testing method, then decision table based testing method, then cause effect graphing method, then error passings we will be seeing in this particular black box testing. Okay, so in black box testing, what we are going to do is, so we are going to go for the testing itself. Okay, so how we are going to test? So whether we are going to test from the bottom to top or top to bottom, let us see right now. So in black box testing, that is software system as black box, we are going to provide the inputs and the testing is going to be undertaken with the help of black box, and output is going to be released. That is, output is going to be produced for the users. Okay. So it is, that is blackboard testing attempts to find the errors in the following categories. That is where we could able to find some errors in black box testing, or after doing this black box testing, what are the kinds of errors that we are going to get are listed here. To test the modules independently, that is the module testing is independently we are going to get, and to test the functional validity of the software so that the incorrect or missing values or missing functions can be recognized. There we are going to go for the um, errors. To look for interface errors, so looking for the interface errors. To test the system behavior and check its performance, and to test the maximum load or stress on the system. To test the software such that the user customer access the system with in defined acceptable limits. That is, we are going to check in the black box testing. Okay, so moving on to the boundary value checking, that is BVC we can say. So as it is saying, so it is going to be having some boundaries. Okay, so here in this picture we are having boundary value analysis figure we are having, so which is ranging from 10 to 255 and 10 to 100, so which is having a and b as two different directions. So just like our x-axis and y-axis, we are having a-axis and b-axis, so where it is having some boundaries like 255 is the boundary of A, that is 10 and 255 is the boundary of A, and 10 and 100 are the boundary values of B. Okay, so we are not supposed to exit, or we are not supposed to cross the limit of those boundaries. Okay, whatever we want to do, we have to do within those boundaries itself. Okay. So in boundary value checking, so what we are going to do is, in this method, the test cases are designed by holding one variable at its extreme value and the other variable at their nominal values in the input domain. Okay. So when we are providing input only, we are going to give the minimum values, that is nominal values, and the maximum values for the given inputs. Okay, so the variable is at its extreme value can be selected at minimum value. Okay, value just above the minimum value and maximum value, and value just below the maximum value, both will be selected. That is, maximum value will be selected, maximum just below that maximum value will be selected, minimum value will be selected, and just above that minimum value will be also selected. Okay, so here the picture is going to give us the boundary value checking. That is, we are having a value, b value on x-axis, and c value, d value on y-axis. So we are having completely 9 points, that is 9 boundaries, which are given as dots, right? So in those dots, we are having one maximum value, that is d value is maximum, and we are having one value below it, and we are having c value as minimum, and we are having one value above to it. And on the other edges, that is on a and b also, we are having the boundary values, and we are having adjacent values to those boundary values as well, right? So in boundary value checking, we are going to fix with the boundaries, and we are going to check for the outcomes, that is what are the inputs that we have provided and how we are getting those outputs, we are going to check. Okay, so then coming to the robustness checking method, that is testing method, so which is called as the idea of BVC, that is boundary value checking itself. So we are going to check for the, so how effectively the product is going to work for the users. Okay, so worst case of testing method, so if it is going to be working properly, then how we are going to check. So all those things are there in the BVC, that is boundary value checking. Okay, here are the few of the examples where the test cases are being given and the test cases are being passed. Right, so then coming to the equivalence class test or class testing. So here the data is going to be divided into the equivalent parts, then the testing is going to be done. So here also it is going to be the completeness we are going to check, and the non-redundancy values we are going to check. So identification of equivalent classes, we are going to have set of rules for identifying the equivalence classes. Then whether it is valid or equivalent, invalid equivalent class, we are going to check. So if it is valid, then we are going to perform the again the test cases, that is assigning the values and going for the testing. Okay. So then we are having state table based testing. So where we are having finite state machines, that is FSM. So and in state transition diagram, we are going to have again new state, ready state, running state, waiting state, and terminated state. So just like our operating system diagram, here also we are going to have the state process state diagram as state graph, which is starting from new state till the terminated state. So it is going to have the new state, ready state, running state, waiting state, and terminated state. So if the state space is created, then it is going to be as new state. So if it is allocated to any of the processor, then it is going to be admitted state. So if it is running within the processor, then it is set to be as the running state, right? So once it is dispatched from ready state to the running state, we are going to say it as the dispatch. Then if any interrupts are there, again we are going back to the ready state. So if nothing is there, then we are moving on to the terminated state. So if something is going wrong in the running state, we are going for the waiting state, and then from there again we are moving back to the ready state, and then we are moving back to the terminated state. Okay, so this is the state space tree, that is, sorry, finite state machine or state transition diagram for state graphs, we can say, right? So for those states we are going to have the table which is represented as state table. So that table we are going to say it as state table. So for that also we are having the diagrams. So the next one is decision table based testing. So based on the decisions we are going to make the tables, whether it is true or false or yes or no. So that table also we are going to represent in the form of a tabular format. So that one we are going to say it as the um, decision table. That is decision table based testing we are going to say. So based on the decisions we are going to make the tables. So that is our decision based table testing. Okay. So then we will be having cause effect graphing based testing. That is, what are the causes of testing and what are the solutions of those testings is our cause effect based testings. Okay, so then we are having error guessings. So that is where we are having some errors. How we are checking with those errors is our error guessings. So this is related to our testings. Okay, that is our black box testings as a whole in separate. Shall we look into the problem? At least one problem,
Yeah, sir.
so that you can understand more, because every problem is related to each other. So first we will take the first one, that is boundary value checking. So be with your pen and paper so that you can write and go for the solution. Okay. So here I am reading out the problem and then we will proceed with the solution. A program reads an integer number within the range of 1100 and determines whether it is a prime number or not. Okay, so what is the system is doing? So it is taking the input, that is reading the integers within the range from within the range up to 1100. Sorry, 1 to 100. Sorry, within the range 1 to 100. Okay, so the system is taking the input value as integer and it is accepting from 1 to 100, that is 100 numbers it is accepting, and it is giving, or it is giving the solution whether it is a prime number or not. Okay, so design test a case for this program using BVC, that is boundary value checking. Okay, robust testing and worst case testing methods. So all these three methods are being asked in this example. Okay, so first we will go for the solution. So test cases using BVC. Okay, so how many variables are there? How many variables we are taking?
2, sir.
Two variables here we are taking. What are those two variables we are taking? We are taking how many variables? We are taking only one variable, whether it is 1 or 2 or 3 or 4 or 5 or 100. We are taking one variable at a time. So how many values we need to take? How many values we need to take when we are checking with the boundary value checking? How many values we need to check? how many values we need to check? So here you could able to see how many values we could able to check. We have to check. Just for our understanding, how many values we have to check?
4, sir.
4 values we need to check. That is minimum value we need to check.
Value. Yes,
Minimum
sir.
value just below it, maximum value. Sorry, minimum value it just above the minimum value we need to check. Maximum value and just below the maximum values. That is 4 values we are going to check, and our n value is only 1. Okay, so here 4n plus 1, that is n value is 1, right? So 4n plus 1 we are going to check, that is 5 values we are going to check. That is test cases we are going to check is 5. Okay, so what are those test cases? So minimum value we are checking. What is the maximum minimum value? 1 we need to check, and minimum value above it we need to check, that is 2 we have to check, and max value is 100 that we have to check, and max minus 1 value we have to check, that is 99, and nominal value is 50 to 55 we need to check, right? So how many test cases we are getting? Completely we are getting the test cases as how many test cases we are getting?
5, sir.
5 test cases we are getting. Okay, so all those 5 test cases we are writing in the form of test case ID, integer values, and expected output. Okay, so for the first test case, that is integer value 1. So whether it is a prime number, is it a prime number? 1 is a prime number. One is a prime number or not? I will check whether anyone is there or not. 1 is a prime number or not? Yes. 1 is prime number or not? So which number is said to be as the prime number?
Two, sir.
No. Oh. Which number we could able to say it as prime number?
The numbers which are greater than 1, sir.
Okay. So 1 is not a prime number, that is expected output that we are going to get. Okay. So 2, in test case 2, we are writing the integer value as 2 and it is a prime number. So 100, it is having multiple factors. It is also a not a prime number. Fourth case, we are writing 99 and it is also not a prime number. Fifth case, we are writing in between 50 to 55. So what is the number that is in the middle of 50 to 55? So we are having 53. So that is a prime number. So out of these 5 test cases, how many tests are passed? That is, how many test cases are passed? How many test cases are passed? 2 test cases are passed and 3 test cases are failed. Okay. Right. So then test cases using robot testing. So here in robot testing, we need to undergo 6 different phases. Okay. That is 6 different testings we need to find. So what are those 6 different things? So that is minimum value we need to find, minimum minus 1 we need to find, minimum plus 1 we need to find, max value we need to find, max minus 1 we need to find, max plus 1 we need to find, and then we have to go for the nominal value. Okay, so that is there in robust testing. Okay, completely we will be getting 7 test cases. So included values apart from those, like 2 are 0 is included and 1 at 1 is included in the test case. Okay, that is the only difference in the second case, right? So is it the same? right? So is it the same? Integer value, integer variables. So we are checking for 0, we are checking for 1, 2, 100, 99, 101 and 53. So 1 is being already tested in the first phase, first test case, 2 is tested, 100 is tested, 99 is tested and 53 is tested. Only two values which we are including or which we have included is 0 and 101, right? Yeah, anyone is there?
Yes, sir.
Yeah, we have included only two values, that is +1 values we have included to the minimum value and minimum value -1 we have included, maximum value +1 value we have included, and those are our test cases. Okay, so that is how we are going to write the test cases, and uh, we are going to go for the solution. Okay, first we need to understand the question, then we have to go for the test case writing like this. So that is there in the first one, that is BVC, boundary value checking or boundary value analysis, we can say. Okay, boundary value checking or boundary value analysis. So in boundary value analysis, that is in BVA, we are having boundary value checking. So there we are having this particular problem, right? So similarly, the case is going to be same for the remaining things. So here it is BVC, BVC, BVC only, that is boundary value checking problems only we are having mostly, right? So again it is BVC. So multiple problems are given in the textbook. Just you can go through all those problems. So then we are having equivalence class testing. So in equivalence class testing also we are having the same question is being given. So we need to divide all these things into the equal parts, and then we have to go for the tabular format. Okay, so that is there in the equivalence part. Okay, so that is how you have to go for the calculation part. Okay, so check for the solutions of each and every problem which is there in this particular uh, part, that is black box testing. Then in tomorrow's class we can still we are having time. So in white box testing also we will be having similar kinds of problems. If they are there, that is fine. So if they are also not there, we can go for uh, yeah, some problems are given, so we can go for the problems in white box testing as well. So there you can go for the drawings, that is diagrammatic part is also we can go and we can give the solution in white box testing. Okay, so so this part is clear, that is black box testing part is clear.
Yes, sir.
So you need to once again cross check with the problems and their solutions. That's it. So problems are already given in the textbook and solutions are also available. That is solved problems are available in the textbook. Just you need to cross check whether they are perfect or not. Okay, and you need to practice how many test cases you are getting and how the test cases are being passed. That is the only thing that you need to check in the black box testing. Okay, so shall we check with the white box as well? You will check with these two things by tomorrow. Yes, shall we move on to the white box testing as well?
Okay, sir.
Yes, please. So then we will check with the white box testing. Okay. So in this particular chapter, we will be coming to see, or after reading this one, uh, we will be able to understand white box testing demands complete understanding of the program logic structure, test case designing using white box testing techniques, basis path testing method, building a path testing tool using graph matrices, and loop testing, and data flow testing method. And then mutation testing methods we will be coming to know when we read this particular white box testing. Okay, so first we will see what is the need for this white box testing, as we have seen for our black box testing. So there is a necessity for this white box testing. Okay, so in white box testing really necessary, that is white box testing really necessary? Can't we write the code or simply test the software testing using black box testing techniques? So the supporting reasons for this white box testing are given below. So that is why we should go for white box testing is given in point wise. That is 5 points are given. So in so black box testing is the second phase for the software testing. Though test cases for black box can be designed earlier than the white box test cases, they cannot be executed until the code is being produced. Okay. So what we are doing, we in white box testing, we are writing the code and we are testing for the coding part. In black box testing, we are completely testing the process. We are completely testing the boundary values. We are testing the tables, state tables, and everything we are testing. But the entire code is being written in the second part, that is in the white box testing. The testings of the code and the related aspects are going to be tested. That is, white box test cases are going to be designed. Okay, so thus white box testing is not an alternative but is an essential stage. So it is not going to be the alternative one, it is compulsory one for the each and every tester has to undertake it. Okay, so since white box testing is complementary to black box testing, there are categories of bugs which can be revealed by white box testing, but not through black box testing. So the bugs are going to be revealed, but not based on the black box testings. This is going to reveal the separate set of bugs and it is going to go for the solutions. So errors which have come from the design phase will also be reflected in this particular code. So therefore, we must execute white box test cases for verification of code as well. That is, unit verification of code has to be done in the white box testing. So we often believe that the logical path is not likely to be executed when in fact it may be executed on a regular basis. So white box testing explores these paths too. That is, code writing and logical path writings are also going to be executed in the white box testing. So some typographical errors are not observed and go undetected and are not covered by the black box testing techniques. Okay, so some of the coding parts or some of the few of the lines are not going to be covered in the black box testing. They are also going to be covered with the help of this white box testing. Okay, so here this is the need for white box testing. That is, whatever the missing things are there, that we can overcome with the help of this white box testing, from the coding part, from the testing part, from the designing part, and from the requirements part. So whatever is missing over there are going to be overcome with the white box testing. Okay, So that is why we require this particular white box testing as a whole. Okay. So in this one, first we will cover the logic coverage criteria. So which is also set to, sorry, in that we will be seeing the statement coverage. That is how many number of statements are there that we need to cover all the statements. Then after covering all the statements, we have to go for the decision or branch coverage. That is loops also we need to cover. And then we have to go for condition coverage. So we have to go for the checking of the conditions. Then we have to go for decision or condition coverage. That is, we have to check for the multiple conditions that are available in the coding part. So then we will come to know what are the drawbacks that are there in that particular code. We will be coming to know. Okay. So what is the logic coverage criteria is covering is, so all the statements it is going to cover whatever the code that you are writing in, whether it is in C or C++ or Java or any other programming language, it covers all the statements. It covers all the decisions, that is if conditions, if else conditions, it covers, and it produces the test cases, and it covers the conditions, that is conditional coverage is there, that is while condition, do while condition, if condition, every conditions it is going to cover. And decisions or conditions, sorry, conditional coverage it is going to cover. And then it is also going to cover, it is also going to cover multiple condition coverage, that is loop within loop is also being covered in this particular logic coverage criteria. That is, whenever you are writing any code by using any of the language, complete coding is going to be tested with the help of logic coverage criteria, starting from the header files till the last value of closing the statement. Right. So if it is a C program, starting from the header files till the closing of the header file and till the closing of the complete structure, it is going to check. Okay.
Okay, sir.
Okay. So so that is the thing which is going to be happening in the logic coverage criteria. And quickly moving on to the next one, that is basis path testing. Basis path testing. So here also it is going to cover the complete flow of the program, that is how the program is going to be, that is how you are writing the programming part, and what is the flow of the complete program is going to be tested with the help of basis path testing. That is, so if you are starting from see, so here we are having, so if you are having if then else path. Okay. So one node we are having on the top. So if that condition is going to be executed, if condition is going to be satisfied, that is if condition is going to be satisfied, one set of uh, statements are going to be executed. So if no condition, that is if condition is not going to be satisfied, then another set of uh, statements are going to be executed. Okay. So here in sequence you could see uh, two nodes are available, one is passing through with the second one. Okay. So here also in basis path testing, what we will see is, so we will cover each and every path that is available for the user from starting node to the last node. So if you are having any decisions in between them, we will also take diversions. With yes condition we will take one solution, with no condition we will take another solution, that is test cases we will pass, and we will go for the solutions of test cases. That is, if test case we will give one solution, no test case, that is yes condition will be giving one solution, and no condition we will also giving the another solution. Okay, so here that is called as our control flow graph. Okay, so we are having nodes, edges or links, decision nodes, junction nodes, and regions we will be having in the control flow graph. Okay, so flow graph notations for different programming constraints are here given here. So this is for sequence, that is without any break. So this is for if then else. So this is for do while, second one, that is C1, and this is for while do, and the last one is for switch case. Okay, if we are having multiple options also, we are having the solutions. Okay, so then moving on to the path testing terminology, we will be having path, segment, path generated, that is path segment, length of the path, and independent path. So that also we will be having in basis path testing, that is a complete path from the starting node till the ending node we will be testing. Okay, without missing any of the case we will be testing. So here you can see the sample graph is there. So we are having, so 4 plus 4, 8 nodes we are having. So if we want to reach from the first node to last node, that is topmost node to the bottom node, if you want to reach, so we could reach from A to B, sorry, from first node to B, sorry, first node to the path name is B, D, F, J we can reach. Otherwise, B, D, G, H we can reach. Otherwise, A, C, E, I we can reach. Otherwise, A, C, G, H we can reach. Okay. So this is the complete flow of that particular uh, given graph. Okay, which is having cycles or which is not having any cycles. So even though it is having cycles or not having cycles, we can reach from starting node to the last node. So that our aim is to reach from starting node to the last node without any deviations. So even if you are having any deviations, that is, even if you are having any conditions to be satisfied, those conditions are to be uh, given within the answer. Okay, that is our basis path testing. Okay, so flow graph testing we have seen, and basis path testing we have seen. Right, so is it clear? So that is logic coverage criteria we have seen, and basis path testing we have seen. Is it clear?
Yes, sir.
So you will be having the path from reaching from source to destination, and you will be having uh, logics in the code. Okay, so those are the things in logic coverage criteria and basis path criteria. Okay, so quickly we will look into the questions of uh, the paper which is written by your seniors or your fellow mates of yesterday, and then we can go for particular session. Okay. So just give me a minute. Once again, I will read out the questions for you. So we have covered so in second part we have covered state. Okay, so black box we have covered completely, and white box also we have covered logic coverage and basis path testing. So in tomorrow's class we can cover the graph matrix, loop testing, and data flow testing, and mutation testing. Okay, so those are the topics which are left. Okay, and quickly I will check out for the questions which are coming or which have appeared in your yesterday's exam. Right. So here the question is, what are all the various types of errors detected by black box testing? Explain. So what are the kinds of black box, sorry, what are the various types of errors detected by black box testing that we need to explain here? So discuss the basic path testing with need sketch. Basic path testing they are asking. Okay, that is also fine. So explain about cause effect graph. So which we will be seeing in tomorrow's class. Write the applications of data flow testing. So that also we will see in the tomorrow's class. Okay. So in today's class, we have covered with mostly 6 questions, right? So those 6 questions we have covered in the today's class. So one more set of paper I am having. Just I will read out the question. If you could able to answer that, that would be very fine. Okay, from the first and second unit I am reading. So explain the model of testing in detail. Also render software testing lifecycle model. Justify whether complete testing is possible or not. So 3 questions kept in one question, which is for 14 marks. So explain the model of testing in detail. So testing model you have to explain. So also render the software testing lifecycle model. Those 4 phases you need to write and justify whether complete testing is possible or not. So one of the myth they have taken and they have posed as a question. Okay, that also you can write. So can you answer this question, or is it going to be bit difficult in answering this question, these kinds of questions?
No, sir, we can answer, sir.
Okay, then so all 3 questions are kept in single question. Okay, that you need to take care. So second question, that is ABT is discuss about verification and validation with an example. So what is verification? What is validation? That you need to write with the help of an example. Okay. Next question is explain about software testing terminology with an example. Terminology they are asking. Okay. So there is uh, no such a thing that you are having any important questions, because in one set of questions, the other set they are covering another set of questions. That is complete unit they are touching. Okay. Then second question, coming to the third question, how do you represent the graph matrices for testing process? Derive the same with the example that we need to cover. State the explore on state table model testing and error guessing. So error guessing you can write. State table based testing you can write. No issue. Next, explore in detail about black box testing techniques with examples and neat diagram that you can write. Black box testing. Okay. So that is related to the first and second unit questions which are being posed in your papers. Okay. So today's task you are having is you have to cover the black box testing example problems and white box testing example problems. Okay. So you need to cover already available problems are there. The problems are available in the textbook. That is whatever the PDF that I have shared to your sir, that is Raya sir, I have shared the PDF document. So which is already available with you. In that PDF, you could able to find the problem and you could able to find the solution as well. Okay.
Okay, sir.
Right. So you have to go through those problems and you have to get the solutions. That is, you will be getting the correct answer only, but you have to check whether you could able to do it without any mistake or not. That you need to check once again. Okay.
Okay, sir.
Okay, fine then. So shall we end our session?
Yes, sir.
Okay. So tomorrow it might be in the evening itself, because I will be in the college till 6 or 7. So mostly when I reach home, it might be 7. So from 7 to 9 or whatever the timings are comfortable for you, that I will be taking in tomorrow's class, and we will try to cover the second unit complete and third unit also complete. So we can cover 3 units by tomorrow.
Okay, sir.
Okay, then fine.
Thank you, sir.
Yeah, you can leave the class. We can close the session.
Okay, sir.
Okay, sir.
Thank you, sir.
Thank you, sir.
Okay, thanks.